Picture this. 8 years ago, the government of India unveiled one of the most ambitious infrastructure ventures in the nation's modern history. A cutting-edge high-speed railway connecting two of its most economically vital cities, Mumbai and Ahmedabad. The price tag? A staggering $15 billion. The timeline? Completion by 2024. The vision? To transform how millions of Indians travel, work, and live. To finance this colossal undertaking, India secured nearly $14.6 billion in loans from Japanese financial institutions, marking one of the largest bilateral infrastructure agreements in recent memory. The project wasn't just about trains. It symbolized India's aspirations to join the ranks of nations with world-class transportation networks. But as 2024 came and went, something remarkable happened. Or rather, didn't happen. The trains never arrived. The stations remained unfinished. And that initial debt of $14.6 billion? It's now ballooned to approximately $18 billion, creating a financial burden that grows heavier with each passing month. Today, this once celebrated megaproject sits in limbo, caught in a complex web of technical challenges, financial constraints, and international tensions. And in a twist that few could have predicted, India now claims that China bears responsibility for the delays. How did a Japanese-funded railway project between two Indian cities become entangled with China? Why have critical German-manufactured machines been held at Chinese ports for months? And what does this reveal about the delicate balance of global infrastructure, technology transfer, and geopolitical rivalry? If you're interested in understanding the hidden forces shaping our interconnected world, subscribe to this channel. You'll get in-depth analysis on the stories that matter most in global economics, technology, and diplomacy. Let's unpack this extraordinary story from the beginning. To understand why this railway matters so much, we need to first understand the two cities it was designed to link. Mumbai stands as India's undisputed financial powerhouse. Walk through its congested streets, and you'll immediately sense the density. Millions of people packed into one of the world's most populous urban centers. This isn't just any Indian city. It's the economic engine that drives much of the nation's wealth. As of 2022, Mumbai's economy generated approximately $310 billion in gross domestic product. That's 9.2% of India's entire national output coming from a single metropolitan area. To put that in perspective, Mumbai's per capita GDP is more than 5 times higher than the national average, making it an island of relative prosperity in a country still grappling with widespread poverty. The city's industrial output is equally impressive. Mumbai produces roughly 1/4 of India's total industrial goods, with its cotton textile industry alone contributing about 1/3 of the country's textile production capacity. It's a manufacturing hub, a financial center, and India's most important port city, all rolled into one. Now, travel about 500 kilometers northwest, roughly the distance between San Francisco and Los Angeles, and you'll reach Ahmedabad, Gujarat's largest city, and what locals call their industrial town. Ahmedabad sits at the heart of Gujarat's cotton-producing plains, giving it immediate access to the raw materials that fuel its dominant industry, cotton textiles. The city's geography tells the story of its development. The Sabarmati River cuts through its center, with the western bank hosting a modern, carefully planned business district, while the eastern bank retains the character of a traditional commercial quarter. This physical split reflects the city's dual identity, honoring its mercantile past while embracing industrial modernization. As Gujarat's primary transportation hub, Ahmedabad connects India's interior regions with its coastal ports. Raw materials flow in, finished products flow out, and the logistics infrastructure that makes this possible has driven decades of economic growth. For years, these two economic powerhouses have been linked by conventional rail lines. Trains have carried passengers, goods, and commerce between them, maintaining the vital connection that both cities depend on. But as India's economy expanded, those aging rail networks began showing their limitations. Journey times stretched to 8 hours or more. Routes became congested. Infrastructure aged beyond its design specifications. The existing railway system, built for a different era, simply couldn't handle the volume and speed that modern commerce demanded. This was the problem that India's high-speed rail project was designed to solve. Indian officials first conceived the Mumbai-Ahmedabad high-speed rail corridor. They weren't just thinking about faster trains. They were imagining a transformation of the entire economic relationship between these regions. The technical specifications were impressive by any standard. The proposed line would span approximately 500 kilometers, featuring trains capable of reaching speeds up to 350 kilometers per hour. If everything worked as planned, that grueling 8-hour journey between Mumbai and Ahmedabad would shrink to just 2 hours. Think about what that means in practical terms. A business executive in Mumbai could attend a morning meeting, travel to Ahmedabad for an afternoon conference, and return home the same evening. Manufacturers could ship time-sensitive goods between cities with unprecedented speed. Tourism would flourish as day trips became feasible. The economic multiplier effects would ripple across both regions. The engineering challenges, however, were substantial. While much of the route would utilize elevated track sections, keeping the railway above ground level and minimizing land acquisition issues, the project also required something far more complex: a 21-kilometer tunnel, including a 7-kilometer section running beneath the sea. Undersea tunnels rank among the most technically demanding infrastructure projects humans attempt. They require specialized equipment, precise engineering, and machines capable of boring through solid rock while underwater. You can't just use conventional construction equipment. You need tunnel boring machines, massive, sophisticated pieces of technology that can cost hundreds of millions of dollars each. This is where things get interesting. In June 2022, Indian procurement officials traveled to Germany to meet with Herrenknecht AG, one of the world's leading manufacturers of tunnel boring machines. The German company has built a reputation over decades for producing equipment capable of handling the toughest geological conditions. During these negotiations, Herrenknecht's engineers recommended a specific type of machine, the horseshoe-shaped shield boring machine. This wasn't a random suggestion. It was based on the unique demands of India's project. Let me explain the technology for a moment, because understanding it is crucial to understanding what happened next. Traditional excavators work by using hydraulically powered arms to dig and scoop material in a repetitive stop-start process. They're excellent for surface work, but limited for tunnel construction. They lack the continuous operation capability needed for extended underground projects, and they can't simultaneously support the tunnel structure as they dig. Shield boring machines represent a completely different approach. These sophisticated systems integrate multiple functions into a single, continuous operation. The rotating cutter head at the front excavates material from the tunnel face. Behind it, automated systems simultaneously install tunnel lining segments, creating a permanent structure. A continuous conveyor system removes excavated material. The entire process happens in a closed, controlled environment that minimizes surface disturbance, critical when you're digging under cities or oceans. The specific horseshoe shield machines that Herrenknecht recommended to India had demonstrated tunneling speeds reaching 6 miles per hour in previous projects. In complex geological conditions, mixed rock types, varying hardness, unpredictable water tables, these German-designed machines maintained impressive stability and performance. For India's challenging undersea tunnel section, these machines seemed like the ideal solution. After extensive discussions, India committed to purchasing 3 horseshoe shield boring machines from Herrenknecht. The total contract value exceeded $330 million. A massive investment, but one that seemed justified given the machine's critical role in the project. India's procurement officials likely felt satisfied with their decision. They'd partnered with a world-renowned German manufacturer, secured cutting-edge technology, and taken a major step toward realizing their high-speed rail vision. But there was one detail that would soon become extraordinarily significant. While these machines bore the Herrenknecht name and incorporated German engineering, they would actually be manufactured in the company's production facility in Guangzhou, China. Part 3. The Chinese Connection, October 2024. 3 massive tunnel-boring machines sat in a bonded warehouse at a Chinese port, destined for India. But they never left. Chinese customs authorities had seized the equipment, preventing its export to India. Months passed. The machines remained in place, and India's ambitious high-speed rail project, already behind schedule, faced yet another critical delay. To understand why China intervened, we need to rewind the clock to 2020, when a very different transaction was taking place. That year, India was pursuing multiple large-scale infrastructure projects simultaneously: coastal highway tunnels in Mumbai, new subway systems in Bangalore, and various other underground construction ventures. All of these projects shared a common requirement: tunnel-boring machines. And when India thought about sourcing these machines, China came immediately to mind. This wasn't arbitrary. Since developing its first domestically produced tunnel-boring machine in 2008, China had rapidly advanced its technological capabilities in this field. Through continuous innovation, testing, and deployment across hundreds of projects within China itself, Chinese manufacturers had accumulated invaluable practical experience. By 2020, Chinese tunnel-boring machines were operating in dozens of countries, earning a reputation for reliability and competitive pricing. China had essentially democratized access to technology that was once dominated by a handful of European and Japanese manufacturers. India saw an opportunity, not just to purchase equipment, but to potentially acquire technical knowledge that could build domestic capabilities for the future. In March 2020, India approached China with a substantial proposal: 18 large slurry water pressure balance composite shield boring machines with a total contract value exceeding $1.9 billion. Now you might wonder why China would agree to such a deal. After all, India-China relations have been tense for decades, marked by border disputes, strategic competition, and mutual suspicion. Selling advanced technological equipment to a geopolitical rival might seem counterintuitive. But China's leadership made a calculated decision. Despite the complex relationship, they chose to prioritize commercial engagement and what they called good neighborly relations. The deal moved forward. China agreed not only to manufacture and deliver the machines, but also to provide the first unit assembled in China, followed by technical support for subsequent units. India appeared satisfied with these terms. Officials expressed optimism about strengthening project-based cooperation with China. Everything seemed to be progressing smoothly. Then came the delivery of the first machine, and everything changed. After China fulfilled its obligation and delivered the initial tunnel-boring machine to India, Indian authorities suddenly became difficult to work with. Chinese technicians who were supposed to travel to India to provide installation support and training found their visa applications rejected or indefinitely delayed. This created an immediate problem. Large tunnel-boring machines aren't delivered as complete, ready-to-operate units. For practical transportation reasons, they're disassembled into numerous components, shipped separately, and then reassembled on site. This reassembly process requires experienced engineers who understand the machine's complex systems: hydraulics, electronics, mechanical assemblies, calibration procedures. Without Chinese technicians present, the machines couldn't be properly assembled or commissioned. Projects ground to a halt. But the visa issue was just the beginning. India also began withholding final payment for the delivered equipment, citing various procedural and administrative reasons. The outstanding balance remained unpaid, month after month. From China's perspective, this looked increasingly like a deliberate pattern rather than simple bureaucratic inefficiency. Some technical analysts who followed the situation closely developed a theory. India was intentionally stalling to give its own engineers time to study the Chinese machines, attempting to reverse engineer the technology without paying full price or honoring the technical support agreements. If Indian engineers could figure out how the machines worked, their design principles, their control systems, their mechanical specifications, India might be able to develop domestic manufacturing capabilities without completing the Chinese contract. There was just one problem with this plan. It didn't work. Indian engineers, despite having physical access to the disassembled Chinese tunnel boring machine, couldn't successfully reassemble it on their own. They had observed Chinese technicians during the initial delivery and disassembly process, assuming they could simply reverse those steps. But the reality of these complex machines proved far more challenging than anticipated. Months passed. The machine sat in pieces. Projects that depended on it remained frozen. India's infrastructure ambitions were being undermined by its own decision to block Chinese technical assistance. This brings us back to those 3 German machines sitting in Chinese customs in 2024. Part 4. The seizure and its implications. When China's customs authorities detained those 3 Herrenknecht tunnel boring machines in October 2024, it wasn't an arbitrary action or a simple trade dispute. It was a direct response to India's failure to settle its debts from the 2020 agreement. From Beijing's perspective, the situation was straightforward. India owed money for previously delivered equipment and had violated the terms of their commercial agreement. Under Chinese export regulations, authorities could, and did, prevent the export of similar equipment to the same customer until outstanding issues were resolved. The fact that these particular machines were manufactured by a German company was, in Chinese eyes, irrelevant. They were produced in a Chinese factory, using Chinese labor and facilities, which placed them under Chinese export controls regardless of who designed them. For India, this created a cascading crisis. Remember that 21-kilometer tunnel, including the critical 7-kilometer undersea section. Work on that portion of the Mumbai-Ahmedabad corridor has been severely impacted by the absence of these machines. The Mumbai Central Underground Station, the only below-ground station on the entire corridor, has seen excavation of approximately 142,000 cubic meters of material. That sounds impressive until you realize the total requirement is 187,000 cubic meters. They're not even finished with the basic excavation, let alone the complex work of installing the actual tunnel infrastructure. Without those 3 tunnel boring machines, current projections suggest the entire project won't be completed until 2030 at the earliest, a 6-year delay from the original 2024 target. Let's talk about what that delay means financially. India borrowed $14.6 billion from Japanese lenders to fund this project. That loan wasn't a gift. It came with interest obligations and repayment schedules. Every year of delay adds to the total debt burden as interest accumulates on funds that aren't generating the expected economic returns. Current estimates place India's total debt obligation for this project at approximately $18 billion and climbing. That's $3.4 billion in additional costs purely from delays, financing charges, and project scope changes. For context, that additional cost alone could build several hundred kilometers of conventional railway or fund thousands of schools and hospitals. But the financial pain extends beyond just the loan itself. Think about the opportunity costs. Businesses that planned investments based on the railway's completion have had to delay or abandon those plans. Tourism infrastructure that would have benefited from increased connectivity sits underutilized. The economic growth that was supposed to justify this massive expenditure hasn't materialized because the railway doesn't exist. Meanwhile, India's broader fiscal picture has deteriorated. In 2022, India's fiscal deficit reached 6.9% of GDP, significantly higher than the government's own targets, and a level that limits its ability to respond to economic shocks or fund other priorities. Total government debt stood at 75.4% of GDP, placing India's debt-to-GDP ratio higher than many emerging market peers. Perhaps most concerning, India's foreign exchange reserves dropped by $83 billion in a single year during this period. While this helped stabilize the rupee against the US dollar, keeping the depreciation around 10%, similar to other Asian emerging market currencies, it also meant India's reserves fell below the internationally recommended threshold of covering 3 months of imports. That's a dangerous position for any developing economy to be in. In this context, paying the outstanding balance to China for those tunnel-boring machines became increasingly difficult, even if Indian officials wanted to resolve the issue.
Part 5. The Blame Game. As delays mounted and public frustration grew, India's political leadership faced a dilemma. Massive infrastructure projects carry enormous political significance in India. Prime Minister Narendra Modi had personally championed this railway as evidence of India's development trajectory and his government's ability to deliver transformative change. When that promised transformation fails to materialize, citizens demand answers. Who's responsible? Why hasn't this been fixed? Where did the money go? Rather than accepting responsibility for the complex mix of planning failures, financial constraints, and diplomatic missteps that contributed to the delays, Indian officials found it politically expedient to point fingers at China. Government statements began emphasizing China's role in detaining the German-manufactured equipment. Media coverage frequently mentioned the 2020 Galwan Valley border clash between Indian and Chinese troops, a traumatic event that left casualties on both sides and severely damaged bilateral relations. The narrative being constructed suggested a direct line. China was deliberately sabotaging Indian development as part of broader strategic rivalry. Indian media outlets ran stories with headlines implying that China was holding Indian infrastructure hostage or weaponizing trade relationships. Some reports explicitly linked the detained tunnel-boring machines to the border tensions, suggesting this was retaliation for India's military posture along the disputed frontier. This narrative had political advantages. It unified domestic opinion against an external adversary, deflected criticism from the government's own role in the project's failures, and tapped into existing anti-China sentiment among portions of the Indian public. But it also glossed over some inconvenient facts. First, the machines were detained because of India's failure to pay for previously delivered equipment and honor the terms of a commercial contract. This wasn't arbitrary geopolitical retaliation. It was a trade dispute with clear contractual foundations. Second, India had created the visa problem that prevented Chinese technicians from providing the technical support that was part of the original agreement. China didn't refuse to help. India refused to allow that help to be delivered. Third, the financial constraints that made it difficult for India to pay for equipment were largely the result of broader economic challenges and fiscal policy decisions within India itself, not external sabotage. India also directed criticism toward Herrenknecht, the German manufacturer. Officials expressed frustration that a European company's machines were being produced in China, suggesting this created an unacceptable dependency on Chinese goodwill for equipment that should have been fully German. This criticism misunderstands how modern manufacturing works. Global companies routinely establish production facilities in multiple countries, choosing locations based on cost structures, proximity to markets, and availability of skilled labor. Herrenknecht's decision to manufacture these specific machines in Guangzhou was a rational business decision, not a political conspiracy. Moreover, India was well aware during the procurement process that these machines would be manufactured in China. This wasn't hidden information revealed only after the contract was signed. If India had fundamental objections to Chinese manufacturing, the time to raise those concerns was before committing $330 million to the purchase.
Part 6. The broader context of infrastructure and geopolitics.
This story of tunnel boring machines and delayed railways might seem like a localized dispute between India and China, but it actually reveals something much larger: the complex interdependencies and tensions that characterize modern infrastructure development. Consider the global landscape of tunnel boring machine manufacturing. For decades, this field was dominated by a small number of companies: Herrenknecht in Germany, Hitachi Zosen in Japan, and a few others in Europe and North America. These manufacturers held near monopolistic positions, which allowed them to command premium prices and dictate terms to customers. China's emergence as both a manufacturer and designer of tunnel boring machines fundamentally disrupted this market. By developing domestic capabilities, China not only reduced its own dependence on foreign suppliers, but also created competition that drove down prices globally. Countries like India, that previously had no choice but to pay whatever European or Japanese manufacturers demanded, suddenly had alternatives. This is part of a broader pattern. China has systematically developed capabilities in what are called strategic technologies, sectors where control of production gives geopolitical leverage. High-speed rail, telecommunications equipment, solar panels, tunnel boring machines, port cranes, and numerous other technologies have all followed similar trajectories. Initial reliance on foreign imports, deliberate investment in domestic research and development, gradual improvement in capabilities, and eventually becoming a major global supplier.